reductase, fluorescence. Okay. So there is, okay. So I think that's the quarter that's missing is what they're going to what Consul is going to add for the protein. Okay. So one of the things is just make sure that you know how protein concentration is determined. That's in the PowerPoint. Okay. Um, know um, know the method that we did to do the protein concentration, and then how to calculate that. So if you guys remember from the assignment that you turned in, know how to do the calculations when we give you the standardized curve, which is pretty much it's a repeat of like everything that we do from like water potential all the way up to nitrate reductase. You're gonna just always refer back to that linear equation. Just know what is y and what is x when we're solving for that. Okay. And then let's see. So then the second part is, okay, nitrate reductase. Um, they will ask you that, I'm pretty sure this question is, what are some biomolecules which have nitrogen? The key answer to that, if I remember correctly, is in the lab manual. And I think the question is written like the lab manual. Give me a second. There's there it is. Uh, yeah, so sorry, really quick. I'm just reading it over the lab. If it gives you so really quick, also in the lab manual, first, second, the third paragraph, there's some really key points in there. Especially when it's giving over a reagent may not bind equally with all types of protein. And then just so forth. It gives you a bullet point 1, 2, 3, 4, 5. Make sure you guys know that, okay? Because that would be a question on the exam. Let's see. Oh, sorry, this is for the protein. I apologize. I'm sorry, guys. I'm all over the place. I just wanted to double check. Okay, one more time. Protein. PowerPoint. You want to go over slide where it says why determine the concentration of protein? How is protein concentration determined? And then you want to go over the Biuret method slide, and then how to solve for absorbent coefficient and the absorbency. Okay. You also want to read the lab manual, and you want especially paragraph 3. Okay. And then just know how to solve. All right. So hopefully I just made that make more sense. Okay. So that's protein. Okay. Did I now summarize it a lot better for you guys? You can do thumbs up.
Yes, that was a lot easier.
Okay, okay. All right, now we're on to nitrogen reductase. Okay, so on nitrogen reductase, um, what are some biomolecules which have nitrogen? That is falls into like the first 2 paragraphs of the lab manual. Okay, let me double check the PowerPoint too. If you guys want to, I saw a couple of you request to record. If you guys want to send that over, you can also do that too. Okay. I'll go ahead and approve that. Just make sure you're sharing with classmates that can attend the study today because of work or other obligations. Okay. So okay, wait, first let me just do what's important on the PowerPoint and then let's what's important on the lab manual and then we can go over the study guide. Okay. So the first part is when I'm looking at the PowerPoint, you want to know what's the importance of nitrogen. You want to know the slide where it talks about nitrate reductase and what it does. Okay. And then you want to know the nitrate reductase activity. And then that's pretty much it for the PowerPoint. Okay, so it's like 3 slides. Then for the manual, the first 2 paragraphs are important. Okay, and then understanding the solutions, because there's a really weird question that is going to tell you, okay, what does this compound do when you did this? So you're going to have to read the manual steps to know what what sulfamylinide does in the process of converting nitrate to nitrite. And then what does the KNO2 do and KHPO4? Just because there's a question that is going to have you match those to what its activity is in this process. Okay. So you'll know that based off of reading just the first 2 pages of the manual. Okay. So that manual is important. Okay. So now, okay, let me look really quick over at the exam. Okay, yeah, that's that question. That question. And then that's that question. Okay, perfect. Okay, again, know how to calculate nitrate reductase activity based off of the graph. Okay, now we're looking over here at the study guide. So what biomolecules which have nitrogen, that's in the PowerPoint and in the lab manual. Okay. Um, what is the measurement of this assay? So what measurement did we use to do that activity? So that's in the manual and in the PowerPoint. And do you guys already know the answers to these? Or you guys just need help knowing where to find it? Anybody?
I just needed help knowing where to find the information.
Yeah. So that's like in the so for example, what is measured by this assay? Um, let's see, where is that? Give me a second. Let me see if I can find it. Okay, so it's here, Hismati, it's on the second. So for example, what is measured by this assay? So it's in the second paragraph of the lab manual where it says, in essence, the assay supplies the sample tissue which saturating NO3, which is nitrate concentration, and then measures the accumulation of nitrite in O2 over a specific period of time. So when you're looking at what is measured, the measurement would be um, the accumulation of nitrite over a specific period of time, and then you run it through the Excel calculations. Does that make sense?
Yes, you said the accumulation of nitrate.
Yeah. So if you look in the lab manual, and then on the second paragraph, it says wait, I just lost myself. The chain, where am I? Oh, there it is. In essence, the assay supplies sample tissues with saturating nitrate concentration and then measures the accumulation of nitrite over a specific period of time. So if you remember, we did added all these things and all these little things to the plant tissue. That was the one where we were adding nitrogen gas to it, and we incubated it in the back. And then I forgot we went over a bunch of stuff and then we measured it back on the spectrometer. And I want to say, I think that was the day that we weren't getting really good measurements with the samples. And so, but we were doing at least doing the steps. So, what was supposed to happen is that any nitrate that was in that leaf sample, um, we were reducing it to nitrite. And then we were measuring the accumulation of nitrite in that solution or in that solvent. And then that's what we put in the cuvette. So that's what the steps, the compounds that we were adding was facilitating the steps to convert the nitrate to the nitrite. Did I do it? Did I do it? Did I do it?
Yes, thank you.
Okay. 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 So the next question is what is the starting material? So you guys should know that based off the explanation. Anybody take a guess? Other than Hesmati.
Nitrite?
The other one,
Nit-
nitrate. Yeah. So remember, nitrate eats ite, meaning that it's the bigger one that will chomp at it. Okay. So nitrate will eat the nitrite. Um, what is the experiment measuring? Um, the color. Okay. Wait, let me look really quick because I'm not sure if this is asking like we know it's measuring nitrite, but I don't know if it's asking um based off of like the what the color agent triggers. Let me see really quick. No, it's just saying that it's just nitrite. Okay. What are their two time periods? So you guys, do you know what the two time period is? That's on the graph. And then we had to do a calculation with the difference between the two.
Wasn't it like T number and then T30 or something
Yep.
like
Good job. So T 30, which was 30 minutes, and T zero, which is zero. Okay. So good job. Um, the question is, I don't think we're gonna have this question, but it's saying, do you think Vmax and Km can be determined from this experiment? Question six isn't going to be on the exam. I wouldn't even worry. What is the color complex made from? That will be embedded in a bigger question on the exam. So know that that's on both the PowerPoint and the lab manual. Again, that question I was telling you earlier, that complex question, name all the reagents in the lab with its function. That's again, those are those 4 reagents. Let me double check it's 4, not 5. The 4 reagents in the lab manual, and I think it's also in the PowerPoint too. Where's that question? And the only reason why I keep hitting on it is because that question's like a big point question. Yeah, it's on the 4 compounds. So make sure you know what they do. Okay. So number 8 is a big ticket item question. Again, 9 is just making sure you know how to do the math in the graph. Okay. Do I need to go over anything for nitrate reductase? That's pretty much it.
No, I don't think so.
Okay. So again, I'm going to reiterate questions 1 through 9 on the study guide, except for question 6. Number 8 is a big hit item. Make sure to review the PowerPoint, the study guide, the lab manual, and the Excel sheet that we did. Okay. Okay. Next one is protein. Oh, protein is on here. Why did I think protein wasn't on here? Okay. We already went over protein, right? Okay, wait, let's look over the questions for that. How was protein concentration measured? Yes. Is it a general specific? Yes. What is the color column? Does the color intensity correlate with the concentration? Yes. If you were doing protein extraction with nitrate reductase, don't worry about question 5 for the study guide. But pretty much we already went over 1 through 4. Okay. Lab 8, we're not reviewing. Okay. Let's go to lab 9. Okay. Let's see. Make it a big mess. Okay, that's the exam. Nitrate reductase. Okay. So we need the lab manual, the PowerPoint. Okay. So PowerPoint goes, the PowerPoint, I say, study the PowerPoint. It really goes into explaining how to answer the questions on the study guide really well with pictures. And so, uh, let's see, 1, 2. I think all the slides are important for understanding the chlorophyll fluorescence lab. Okay, so remember, know the difference between dark reactive and light reactive. Okay, light reactive, you'll know because there's going to be one key measurement in that isn't in dark reactive. So what is that? If you guys remember. Anybody? I went over it in lab when I was showing you the Excel sheet. Anything? Okay. So I'm gonna let you think about it and then I'll go back to visiting that question. Okay. So so every single slide on the PowerPoint, it. Know it inside out because there's going to be quite a few questions on that. Okay. Um, let me look at the lab manual and then pretty much the entire lab manual. Yeah. The lab manual will help you understand the pictures in the PowerPoint if you don't understand the pictures. So the things that you're going to want to know. Okay, let me look at the example really quick. It's going to have a question with the light response curve. So make sure we understand that from both from the PowerPoint. And then it's going to have you do a calculation. So make sure you understand how to do the calculations from both the last two the last two quizzes and the Excel sheet that we did in class. Yeah, it's going to be talking about questions on the reaction center and the electronic acceptors. So that is on the PowerPoint. Remember, that was the one that I was talking about, it being a little drum. Um, and then it's going to ask you about the solar energy that's being absorbed. So know what that is. Okay. Again, light response curve question is on here. So yeah, a lot of calculation questions on here. Okay, so if we're looking at the study guide, so know what chlorophyll fluorescence is. It's in the PowerPoint. It's also in the lab manual. The dark adaptive, light adaptive, both of that. So if you guys had time to look at it, what's the difference between the dark and the light? Oh my gosh, you guys are killing me. Did I get a chance to look it up? Okay, what's the key? What's the keywords? Dark reactive, light reactive. One requires what?
Uh, light requires light.
Yes, exactly. So when light is activated in the electronic or in the PS2 system and the PS1 system, what are we looking at? Starts with the E.
Energy.
I'm sorry.
Energy.
Right. Well, the electron. So we're looking at the electronic transport rate. So that is the difference between when you're looking at dark reactive information versus light reactive information, is that if you see anything that says electronic transport rate or an electron moving, that is like, I shouldn't say electron, excuse me. Let me rephrase it. You see anything that's talking about an electronic transport rate, you know we're now talking about light reactive or yeah, um, light adaptive or light reactive, anything light, because the electron is being activated and it's moving. So exactly what it says, electron transport rate. It's the electron transporting, aka moving, and how fast it's moving, the rate that it's moving. So electronic transport rate. And that is only activated when we have a light source that is exciting the electron to move forward. So make sure you know this stuff, okay? Okay. So this question, when you're looking at the light adaptive data for chlorophyll fluorescence, is there a variation of light intensity? What would that be? So that'd be yes or no.
I'm gonna say yes.
Correct. Why?
I don't know.
Okay. I'm going to read the question again because the answer is in the question. When you're looking at the light adaptive data, okay, keyword light for chlorophyll fluorescence, is there a various light intensity?
Oh yeah,
Because
there's variation in light.
exactly, there's light. Okay. So when you're looking at the dark adaptive data for chlorofluorescence, is there a variation of light intensity?
No,
Why?
because there shouldn't be any light.
Correct. Exactly. Okay. So there you go. Okay. So the next one is chlorophyll fluorescence is the light energy that is not used in photochemistry. I'm going to let you guys find that out. That actually is in the PowerPoint and in the lab manual. And then the photochemistry, I'm going to also let you guys figure that one out. That one is in the lab manual and the lab PowerPoint. Uh, Question 8, what are the three fates of light absorbed by the plant? Um, I wouldn't worry about question. Wait, let me double check. Um, I mean, I wouldn't really worry too much about question 8. It's just twisting, it's just making you look at things forward and backwards. So, it's up to you. It just helps you better understand how to answer some of the questions. But if it's not like it's not a specific question on the exam. 9, fluorescence determines the light use effect on light dependent. Question 9 is a good one to know. And then 10, of course, is what I was telling you earlier. How do you calculate the electronic transport rate and so forth? So that it look at your Excel sheets for that, okay? So, and then your quizzes for that one. Okay, is there any more? Uh, there was that side note, don't worry about that because we didn't have that we didn't have that in lab. Okay. Is there any questions for this section?
Nope.
Okay. Okay. So the lab 10 is the plant growth analysis. That is your lab, the one that you grew the sunflower plants. So what is the purpose of the lab? So what was the purpose of your plant growth project? Do you
Is
guys
it like
remember?
determining which fertilizer would help the plants grow better?
Right. It's just basically, yeah. So another way to say it is it was just know that it was factor cap. So we're trying to find out is the fertilizer statement true or false in its claim. So, and exactly what you're saying, Hasmati, with with it being able to grow. Like, will it make it grow better than the control? Okay. And then we will have a question where it's like, why are the measurements, why do we do it in dry weight instead of fresh weight? Well, we measure fresh weight, but why do we also measure dry weight?
Um, it's because fresh weight still retains water.
Yes. Okay, exactly. And that water will do what to the measurements? It'll do what to the data? Sorry.
Wouldn't it throw it off because the different plants have different variations of water?
Exactly. Exactly. So there we go. if the SLA of a plant A is blank and plant B, which one is thicker leaf? Oh, this is no, don't worry about question 3. Actually, let me double check. Hold on. Let me double check. Oh yeah, no, you do need to know this one. Okay. So SLA is the specific leaf area. Okay. So if a specific leaf area of a plant is 142 centimeters per gram and plant B is 170 centimeters gram, which one is a thicker leaf?
170 grams, centimeters.
Why do you think it's that?
Just because it's bigger, has more leaf area.
Thicker, yeah, exactly. I just want to make sure the way this question is asked. Right. And it's correct. And it's because it's measuring um per gram. It's actually, I want to, no, actually, sorry, Christian, it's backwards. It's 142 because it's saying per gram. So the weights are the same, but the area is bigger in plant B versus smaller in plant A. Do you see what I'm seeing?
Mm.
So if this was 170 grams per centimeter square, then you would be correct. Meaning in 1 centimeter square, it weighed 170 grams. And in the plant A, in 1 centimeter square, it weighed 142 grams. But this is said 142 centimeters square per gram. So they weighed out a gram of tissue, but the tissue was bigger in space for plant B, which means the leaf was thinner because it didn't have the thickness to make up for the weight versus plant A, which was 142. It was smaller, which means it was fatter.
Okay, that makes a lot more sense.
Okay. Good thinking in this through though. Okay. So understanding the root and shoot ratios. So that's the one where we were calculating all your plant tissue above ground in ratio to its lower ground mass. So know how to calculate the values between the two and what that means. So we were discussing that in class. So and I love using Cecil as an example because it's like a double question within the product. So Cecil claims that it builds these bigger root masses so that it absorbs more nutrients in the soil to replicate what's happening biomass wise below ground, up ground. So it's saying that it's going to translocate a lot of nutrients, a lot of water into the top part of your plant. So therefore, your top plant is going to be bushy and beautiful and all this other stuff. Um, and so being able to know and understand when your root mass is lower or higher, what that means in ratio to your mass of your leaves and stems above ground. So just on a side note, you don't want to make the assumption that just because your root mass is lower up below ground, that it is going, that it signifies, or how do you say it? Um, that it's going to result most of the time or all of the time in lower growth above ground. Um, and the reason why, and you don't want to also make this assumption backwards. So if your root mass is more, but your canopy above is lower in weight, so um, you don't want to make the assumption that uh, that there's something, how do I say that? Um, that that's always the case. There you go. You want to rarely, like, remember I was saying like a healthy plant, 50% of the weight should be above ground and 50% of the weight should be below ground. But you're going to see a shift between the two. Some in the plants that we worked on, they didn't have this particular case, but in the some of the research that I've done in the past, the root mass will be low in weight, but the upper part will be kind of big and dying. And then, or I've seen the root mass be a lot, but the plant be short and stocky and it just doing all these weird things. And it could signify that there's something else happening in the plant. And so, such as nematodes, like root nematodes. Root nematodes will get into the root system. They'll damage the root system. So they'll cause the root system to either reduce in mass or it'll infect the root system in which it creates these galls, which is like putting plugs into the xylem and the phloem of the root system so that the nutrients can't get into the plant. So even though your root mass is bulky, and it has all of these like little nodes or little knots. It's be and your plant is stocky on top. It's because the nematodes prevented the nutrients from getting up to the plant and creating that equal balance ratio of upper canopy mass and lower canopy mass. So just kind of be cautious when you make it be cautious when you kind of think it through when they ask you a question like about the ratio. Okay. So hopefully that kind of, I didn't make it more complicated for you guys. Okay. Um, and then what is the shoot system? So in this particular case, it's asking you like what's the shoot's purpose for the plant? So if you guys remember from early lectures, do you guys remember what the shoot purpose is? What does the shoot do when it's connected to the leaves and connected to the roots?
It moves minerals and water.
Yes, it's the highway of the plant, okay? It's getting everything from the root system up into the leaves and fruiting bodies and flowering structures and vice versa. It's transporting all of those photosynthetic energy downwards into the root structure, okay? So just know that. Okay, and then any other questions else? So no, so I could give you, so on that exam, I could give you some data, some statistical data that we were discussing in class. I'll give you an Anova and then I can ask you, um, this product claims blah, 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 blah. According to the Nova, when we did a root to shoot ratio or root to, or I did, I don't know, biomass ratio. This is what the statistics, the Anova said for the control and for the experimental. Interpret the data for me. Okay, so when you see the experimental you see the Anova, what is the things that you're supposed to look for? So remember when we ran your data through JAS and we did an ANOVA, like let's say we did root mass, right? And we ran an ANOVA. What was the first thing we were looking for in the ANOVA?
Was it a p-value?
Yes, exactly. Okay, so our p-value that we wanted it to be in was what?
Isn't it the 0.05?
Yes. Yes, exactly. We wanted to be, but we would be okay with a 0.1 value, right? Okay. Now, let's say when you look at the ANOVA, the p-value for the experimental is 0.0003 and the control was 0.8. What does that tell you? So I'm going to write it here, okay, in the comments. What did I say? 8? Actually, it'll just say p-value. Sorry, I made this mistake. Okay. The p-value for experiment is 0.003. Okay. Then you look at the mass of control. There we go. Sorry. Which is the means, right? Okay, so now there we go. So the p-value of the whole treatment experiment is 0.003. So do we have a significance or no significance?
No significance?
We have no, opposite. We do have a significance because it's less than 0.05. Okay. So I'm going to write that down. P-value was 0.003, making it significant because it is less than 0.05. So if you look in the comments, Amanda, does that make sense?
Yes.
Okay. Okay. So now we look at the p-value and we go, okay, now we have a significance. Then we look at the details of the description of the data. So the description of the data, you go into that thing and it says, okay, the control means weight, the mass of that control was on average for all your samples 0.873 grams. Okay. And then for the experimental, the mass was 1.563 grams. So when you say there's a significance between the two, which one benefited from the significance? The experimental or the control?
The experimental.
Correct. And why is that?
Because it has a greater means of mass than compared to
Exactly. So when you would write your statement, you would say, according to the the treatment did improve the plant growth, um, signified by there was a significance between the control and the experiment through the Anova that said it was 0.0003 p-value, and that the experimental improved the weight of the plant based off of the biomass being greater in the experimental than in the control. So does that make sense?
yes.
Okay, so there will be a question like that on the exam. Okay, now we could trick you, and we could either give you a p-value that is not significant, but I could give you a p-value that is 0.059. Okay, so it's, what would you say if I gave you a p-value that was like this?
It would still not be significant.
But is that a hard like
Um,
not significant?
Probably not, just because it's still benign. Maybe you just have to redo your experiments, see if it'll be a different outcome.
You could do it that way, or you could just accept it as it is and saying, hey, the p-value, although the p-value is not um, majorly significant, it's moderately significant. So that means it's borderline significant versus not significant. So that tells us that either the experimental, like you said, needs to be redone, needs to be run longer, or we just probably need to do another sample set just to confirm it, that so that we can get a confirmation hard significant or hard not significant. And so, so when you do that, it's all about interpreting the data. So it can be kind of like a little tricky question. What if I were to switch so the p-value is still 0.003, excuse me, but when you look into the mass, instead of the control, I'm going to write it down so you guys can see, um, is backwards. So how would you interpret that? Can we get something from like Luca or Chaime? So you showed a significance. So you say, yes, this experiment showed a significance. However, the control was 1.563 grams and the experimental was 0.873. So how would you interpret that data? Don't be scared. Anything is something. This is why I'm here too. I'm here to help guide you using the right terminology. So don't be scared. Take a stab at it. Anybody? Christian, Amanda, Jaime. The question was, how do you, so we gave you the p-value and that there was a significance, you showed a significance in the p-value because the p-value was 0.0003. But when you looked at the descriptive data, the control weight was 1.563 grams and the experimental rate was 0.873. So how would you interpret that data?
Maybe that the product didn't do what it was supposed to do.
Right, right. Good job. So, yeah. And why is that?
Because the mass for the experimental is less than the control.
Right. Exactly. So then that would be the statement is that you can either say, hey, the product, uh, you never want to call out a product and say, oh my God, they're the bad guy, right? But you always want to say, with this particular plant or this particular experiment, the product didn't work. And so therefore, and the reason why is because we showed a significance between the growth, but because we had the p-value of 0.0003, but the weight of the control weighed more than the experimental. And so therefore, um, the product didn't work. Now, this is kind of cool for you also to think about this. So remember I was talking about nematodes, right? And I was telling you like how nematodes inhibit the growth and stuff like that. So if the experimental was plants treated with nematodes versus the control, would this be good data or bad data?
Bad data.
Why would it be bad data?
Um, because they're different. They're like one's being impacted by something else.
Yes. But it can also be good data because it is showing that the nematodes cause this damage. So, so if I were to do the experiment again with nematodes and show no significance, then what that tells us is that tells us when we send out the data to the farmers is we tell the farmers, okay, you can have this nematode in your citrus orchard, but we've looked at the data. It doesn't change the yield between trees that don't have nematodes versus trees that do have nematodes. And so therefore you don't have to worry about treating the nematodes in your orchard. So just kind of think about like how to critically think the data. Will we give you anything in that complex? Probably not. But the scenarios that I just gave with the descriptive data versus interpreting the ANOVA, that will be on the exam. Okay. So make sure you get yourself practice with that, looking at your experiments, your experiment data. Okay, so the last lab we're going to go over is the photosynthesis lab. So this one was really weird because we didn't do the photosynthesis um, lab in class. We watched the videos. And so oh my goodness. The questions are going to be on the videos and on the lab manual. I put the PowerPoint up that I was supposed to go over for you guys to look at. I don't know if it's going to be helpful or not, but mainly understand the gas exchange. So understand carbon dioxide with using that equipment from that video, how that works, how the equipment works, how the equipment import outputs the data and how the data is important, what that equipment measures, what that equipment controls. So that part where she's explaining, okay, we can control the rate of and the quantity of carbon dioxide going into the little cuvette, the little chomper cuvette. And then it measures the output, like the the remaining carbon dioxide from it. So we know what the plant is using or absorbing of carbon dioxide or the carbon gas, because if I put 400 parts per million into here and my output is 300 parts per million, then that tells me that there's 100 parts per million that the plant absorbed and went to use for some kind of photosynthetic activity that I was telling it. So make sure you understand those videos, okay? And then, so question 1, how is photosynthesis measured? That's in there. Why don't we use oxygen to measure photosynthetic rate? That's a critical thinking question. I think it might, you can probably look in the PowerPoint for it and then in the thing, but it's more like critically thinking it. What are the constraints of photosynthesis? That's in the video. What does that, let me look great really quick about this other one. Hold on 1 second. Let me find the exam. Um, I don't think, no, I don't think that's going to be on here. No. So question 8 won't be on there. 9 won't be on there. 10 won't be on there. 11 won't be on there. 12 will be on there. And then let me explain 12 to you just because, oh, you know what? I take that back. My apologies. 8 will be on there, but 9, 10, 11 won't be on there. Okay. So let's do this again. 1 will be on there, 2 will be on there, 3 will be on there, 4 will be on there. 5 will not be on there. 6 will be on there. 7 will be on there. 8 will be on there. 9, no. 10, no. 11, no. 12, yes. And 13, yes. Okay. So of these, the ones that I said yes, you'll be able to find that in the video, the manual, and the PowerPoint. But let me explain 12 for you a little bit, okay? So let's see if I can find this. Okay, so it's asking you, it says, would a shade plant have a higher or lower QE value compared to a sun plant? Okay. So for this place, shade ones will have a lower one. And if you look at the PowerPoint again that we didn't go over in class, that's up on the thing, it will show you the picture where it shows the curve being less. And it's because when we remember that when we measure photosynthetic energy, we're measuring the input of carbon dioxide and light that excites the electrons. So the water, we have water that's already in the plant. So we're exciting the electrons. So we're looking to see what that is. But if we have low light, okay? But we have like a lot of carbon dioxide and we have plenty of water. That light is only going to do so much before it's at its saturation point, and then it's going to plateau because there's not enough light energy source to keep going up and up and up. Okay. So it kind of just plateaus and it's like stays at this level because it's like, okay, this is the amount of light that we're getting. We can't do any more photosynthetic energy with the amount of carbon dioxide we have in here and the amount of water that we have inside the plant. Okay. Versus if I were to just full blown put sun on that leaf, and we have lots of carbon dioxide and lots of water, it's going to create a higher peak because it's going to go up faster. And then it's going to plateau because remember, it's like it struggles after 80% because we're just going to start frying the plant after that. Okay. Not because there's not enough water and not because there's enough carbon dioxide, but because we're just like, it's like us getting a sunburn. We're starting to sunburn the plant. And so we don't want to really do that. So it kind of like has like a 80%. So you'll kind of see it plateau like right around there. Okay. So, but if we were to look at the graph differently in the sense that there's limited carbon, but there's optimum light, our peaks may be higher, but our plateaus are going to be different because there's limited carbon dioxide in the plant. So that limits its plateau. Okay, so kind of understand that when we're looking at this, the graph that has the steeper slope and the higher plateau is the one that's full sun. Okay. Then question 13 says, does shade and sun plants utilize the same light intensity? So think about that question. It's saying, does a leaf that's in the shade versus a leaf that's in the sun, are they utilizing the same light intensity?
Nope.
Correct. So I want you to think of it like this. You're in Fresno, it's 110 degrees, and you're walking on the sidewalk with no trees. And then you see across the street, there are trees that are shading in the area of the sidewalk. You are more likely to go across the street and walk under the shaded trees because you're not going to feel the intensity of 110 degrees on your skin when you're walking in full sun versus walking in the shade, which can lower the temperatures like 20 degrees. So all of a sudden, you're going from walking in 110 to 90 degrees temperature. And you tend to do that. And you're not squinting and all this other stuff. So think of plants the same way too when it comes to this particular question. Other than that, that's pretty much it. So things, one more time, we're going to review this. Read the lab manuals. Read the PowerPoints. Make sure you understand those pictures. Make sure you can answer these questions and go over your assignment graphs, go over your quiz practices, because there's going to be a lot of graphs, a lot of equations, a lot of critically thinking things through. So make sure you can interpret the data, especially with the growth analysis. Can you interpret it in Anova, and can you explain it based off of the description? So any other questions?
Is there going to be any questions based off the sensory lab?
Yes.
Is there anything we should try to remember about the lab?
Well, do you remember what the two things that we tested were?
The magic berries and I forgot the name of the flower.
Miracle berry and buzz button flower. I just put it in the comments.
Alrighty.
Yeah, so there'll be like one or two questions on that. Anything else?
I think that was it for me.
Okay, anybody else?
Will
were you recording or like will you be recording it and putting it on the canvas or?
No. You mean the study night?
Yeah.
No. But you can reach out to, I think Luca and Christian were recording, so if you wanna,
Okay. Sounds
yeah.
good.
And the only reason why I don't post it on it is it's because you guys I make a lot of exceptions during the semester. And sometimes I feel guilty because I think it's unfair for people who turn things on time and then I extend it. And I can see students that are like me that were up until like 11:59 submitting it at 11:59 to turn things in. And then I come in and I go, just kidding, I've extended it, whatever, because, other students also need the extra time for whatever reason. So when I do these things, it's me rewarding you guys for making the time to show up. Um, and so if you want to record it, I grant the recording. If you want to share the recording with people, that's your kindness. But this is my rewarding you guys for showing up and taking the time to meet with me and getting extra information. So that's why I just don't post it. Anything else?
I think that's it.
All right. Good luck, you guys. I'm doing another one at 8 o'clock if you guys want to do it again. And then I don't know, do you guys want to like a fun, like, what do you call it? Like Jeopardy I can do on Sunday?
That would be cool. I think it'll be
Okay.
easier. And
Okay. So that gives you time to study today and tomorrow. And then maybe I'll do a Jeopardy around like, I don't know, 8 o'clock tomorrow.
Yeah, sounds good.
Okay. All right, cool.
Thank you.
All right. Good luck studying, you guys.
Okay, thank you.
All right. Bye.